Hello, I'm Amaan Syed from CommsB, and this is my team, Keshav Pandya, Keyur Patil, and Rikhav Satra. This is our IS IA1, and our topic is Network Traffic Analyzer. Let's dive right in. To analyze network traffic, we are going to be using a very powerful tool called Scapy. Scapy is a powerful Python library for network packet manipulation. It allows users to create, send, modify, and analyze packets across multiple protocols. It is widely used in cybersecurity, specifically network debugging. In the test.py file, we first import the Scapy library and use it to print all the interfaces available on a device. Let's run the code. We can see the multiple interfaces available. We are going to be using the Realtek RTL 8821CE as that is our Wi-Fi card and our adapter. Moving on to packet capturing, I'll be explaining how we can capture packets flowing through the network in real time. Using the sniff function in Scapy, we can easily obtain the packets in a specific interface as well as the number of packets we want to capture. Let's go through the code. First of all, we import the library, then we define a function called packet capture, which takes in two arguments, the interface and the count. Then we use the sniff function to capture the packets. Talking about the sniff function, by default it captures all types of packets, including Ethernet, IP, TCP, UDP, ADP, and more. It stores them in a list, allowing further inspection or analysis. The function then returns the packets. The Realtek interface is used as specified before, and we loop through the packets array and print the summary. Let's run the code. As we can see, we have captured 10 packets from the interface, and we can see currently they're all been captured as the UDP packets. Now let's move on to Keshav.
Yeah, so I'll be explaining traffic logging. Uh, uh, Firstly, traffic log, as Aman discussed, Scapy is very powerful tool for traffic logging also involves Scapy to capture network packets and log them to the file for analysis or record keeping. I'll explain some code for you. Uh, 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 we are importing Scapy. Then we define a function named as packet capture in which we are passing parameters such as interface and count. Here we are again using the snip function, which is a built-in Scapy function that listens for network traffic on the specified interface. The iFace parameter is the network interface such as Wi-Fi or Ethernet on Linux. The count parameter specifies how many packets to capture before stopping. Then moving ahead, we have a variable named as captured packets in which we are using packet capture, the function we have above defined. And as Aman discussed, we are using the Realtek RTL. Uh, then moving ahead, we are again creating a new function named as traffic logging. Now that we have captured some network packets, we need to log them to a file for further analysis, right? So here we open the log file in write mode and iterate over each captured packet, writing its details into the files. Yeah. Uh, then we are defining the log file path and calling our function traffic logging. Can we run the code, please? Yeah. Okay. On running the code, we got the log file in which, as you can see, IP, UDP, TCP, these all are visible. So the packet contains an IP layer and a TCP layer. There is a source IP and a port, the destination IP and port. There are some flags. I'll discuss some of them. Sync flag, that is start of the connection. ACK, that is acknowledgement of received data. Push, which basically pushes the data immediately. FIN, graceful termination of a connection. And RST, abrupt the termination of a connection. Uh, Again, moving to the traffic logging code. Yeah, in the final line, we are just printing that if we have logged to the network or not. So here we have traffic log to network, traffic dot log. Yeah, I'll pass the baton to Keyur Patil.
Thank you, Keshav. I will be explaining anomaly detection. Uh, Anomaly detection involves using SCAPI to detect anomalous network packet based on the packet size and comparing them to a specific threshold. Now, walking through the code, here we have our Wi-Fi interface, and through that interface, we are capturing the packets. This function was previously explained by Aman and Keshav. Here we are just passing the Wi-Fi interface and the number of packets that we have to be captured. So we have set the threshold amount. This is taken 1500. Um, this is the default maximum transmission unit for Ethernet, which is 1500 bytes. The single packet cannot exceed this size before fragmentation. Mm. So all this captured are then passed on to the memory detection functions where each packet is analyzed and its size is compared with the threshold. If any of the packet length exceeds the amount of the threshold, it is added as an anomaly. Then all the anomalies that are detected are written. Now I will the code. So here, as we can see, like 100 packets are being captured and all have some different sizes. Like some nearly 1,000 size packet display that they are the video streaming and HTTP data. Small packets display like TCP acknowledgement packets and some normal web browsing. Like, and in the final, we can see that zero anomalies are detected, which shows that this was a normal browsing and no flooding or like anomalous packets are any captured. Now I will pass the control to Rikhav. Thank you.
Hello. Uh, I'll start explaining the protocol analysis. So, network traffic analysis is a crucial aspect of cybersecurity. This project utilizes CAPI. The script captures network packets in real time, analyzes them, and provides a breakdown of the different protocols detected. So network communication occurs using different protocols such as TCP, UDP, and various application layer protocols such as HTTP, DNS, and ICMP. So each packet traveling over a network follows a specific protocol, and analyzing these protocols can help in identifying abnormal network behavior, detecting potential cyber threats, optimizing network performance, and debugging some network issues. So by analyzing packets, we can determine which protocols dominate a network and whether there is any suspicious or unexpected activity. So let's walk through the code. We start by capturing the network packets. The function we've used is packet capture. Uh, it is responsible for sniffing packets from a specified network interface. It captures a defined number of packets and returns them for further analysis. Next, we move on to our main subset of code, which is analyzing the protocols. We've used the function protocol analysis, and the function protocol analysis takes a list of captured packets as input, and these packets are collected using the sniff function in the previous step. We initialize the protocol counter when we initialize the empty dictionary called as protocol count. This dictionary will store protocol names as keys and their occurrences as values. Next, we map the protocol numbers to names. Then we loop through each captured packet and check if the packet contains any IP layer. Then we extract the protocol type. If the packet has an IP layer, we extract the protocol number using the packet IP.proto. This returns a numeric value representing the protocol type. Then we count the occurrences of each protocol. So we check if the protocol name already exists in the dictionary. If it's yes, we increase the count by one, and if it's no, we add it to the dictionary and it sets the count to one. So we run the code. So yeah, as we can see, we have 17 UDP 10 UDP packets. So we'll conclude by so today we have explored the capabilities of our network traffic analyzer, which is a powerful tool in designed to monitor, analyze, and interpret network traffic in real time, from packet capturing and protocol analysis to anomaly detection and traffic logging. The system provides essential insights for network administrators and security professionals to ensure efficient and secure network operations. Through the use of Python and Scapy, our tool enables users to detect network anomalies, troubleshoot issues, and enhance security by identifying potential threats. With a user-friendly interface and robust functionality, this project contributes to improving network visibility and strengthening cybersecurity measures. Thank you.